Hello everybody. How are you? I hope you're doing well. So today we're gonna discuss a little bit about the Genecology Lab report, and we're gonna see how to calculate all the stats that you need for your report, and also how to produce the graphs for your report. So it's gonna be a Excel tutorial. But before we get started right here, it's very important that you read very carefully the two Word documents that we posted on Canvas. The first one is the stats primer, and the second one is the assignment instructions. And it's also very important that you watch Sally's video before starting here, okay? I hope you enjoyed this tutorial, and any further questions that you might have, just contact us by email or also meet us on Zoom during our office hours. So let's get started. So before we get started with the spreadsheet with all the values and all the data that we have collected from last year and also 2007, I would like you to have a look at this file first, which is called block map. This is just for you to have an idea how we collected the data and for you to know a little bit more about the experiment, the Common Garden experiment with Gary Oak that we have at Totemfield. So here you can see 4 blocks out of 12. So this experiment has 12 blocks, but we are going to be analyzing data just from 4 blocks. This is what we normally do. We go with the students to Totemfield and we ask groups of students to go out and measure a bunch of trees. So here I'm showing the first block, for example. One group would take this green part, a second group would take this white part here, and the third group would take this green part here. So each cell represents a tree here, and this experiment was thinned because the plants are big right now. And just for you to know that each number here represents a tree, and the X is where the plant was cut down. So it's not here anymore. So this is the first block, and then because we had many groups per class, each group took one of this group of plants here. Okay, so basically what we have here, it's our data. We have in the first column, we have tag ID, which is basically the plant ID, and each plant has a number in the experiment. In the second column, we have provenance, from where the seedling came from where the plant came from. In this case here, if we look at the first row, we will see that the plant 911 came from provenance 7. And then if we look at the map here, here are all the provenances, and provenance 7 is right here. In the third column, we have variety. In this case, in our experiment, we have 2 different varieties of Quercus garryana. The first variety is garryana, so the species is Quercus garryana, variety garryana. And the second species is Quercus garryana, variety Semoda. In the fourth column here, what we have is height of the plants in 2007, and then in the next column we have height in 2017. In the next column we can see circumference that was measured last year. This is basically what you would be measuring if we were able to be outside measuring plants. So this column here and the next column as well. So the next column is basically the number of stems, and you will see that for most of the Garryana, you will see between 1 and 2 maximum stems. For Semoda, you will see that the plants have multiple stems, varying from 1 to 8. You are not seeing any rounded value here because this is the average. Multiple groups measure the same plant, and this is basically the average. So this 1.5 is probably just because one group measured as 1 and the other group measured as 2, and here's the average value. Moving out to this sheet here, we have all the climatic variables, all the climatic information that we need to test your hypothesis. Here we have the values, and here we have the explanation for each information that we have in the header here. So provenance, variety, latitude, longitude, the distance in kilometers from totem field, from where the experiment was planted, mean annual temperature, provenance, mean temperature of the warmest month, and provenance, mean temperature of the coldest month, and provenance means summer precipitation. So from here, we're going to extract our climatic variables. And then in the third sheet here, what we have is the stats calculator. So everything we have to do here is to bring values to fill here with the data that we have. So we first need to organize our data in order to put in here. This calculator here is gonna perform a t-test and give us a t-value and a p-value. So there are 2 t-tests here, which are part of your hypothesis testing and also the graphs that you need to make for the report. And then we also have a linear regression calculator here, which is not going to give you the graphs that we are asking for, but it's going to give you a p-value. It's going to give you a r-squared every time your test is being significant. You're going to also be able to see a r-squared value. And also, if it's significant, you're going to also be able to see the slope of the curve here. Okay, so everything we need to do is organize our data and put in here. Okay, so let's start with the stats calculator. We first are going to perform the t-test for the heights in 2017. Okay, so like I said, everything we need to do is to put the values for Garryana here and the values for Semoda here, and then our t-test calculator is going to give us the t-value and the p-value. So t-test basically, it's a way that we can test our hypothesis for differences between 2 means. So we are testing the mean height value for Garryana against the mean height value of variety Semoda. So we are comparing these 2 groups, and the t-test has got a hypothesis for us, right? That the 2 groups are the same or don't differ in height, okay? So to do that, we go first to our data. What we can do is first click here, right? Select this first row, activate our filter. We can basically just select Garryana first, right? So all the values for Garryana are here. So because we are testing height in 2017, we can select all values from this column. I'm going to copy these values and I'm going to paste all the Garryana values right here. With the right click, I'm not going to paste directly. I'm going to paste special, and I'm going to paste values. Otherwise, it would paste also the formatting from those cells, and I don't want that. I just want the values here. So I'm gonna deselect Gariana and select Semoda. So now that we have Semoda selected here, we are gonna go back to our height. We have all the heights here, and select this entire column. Copy it. So we can also use this symbol here to copy. And paste it right here. Right click, remember to use paste special values, and here we have it, our test. The higher our t-value is, bigger the difference between these two groups here. Only by looking at the t-value, we are not able to tell if it's significant or not, the difference. We also calculate a p-value to see if this t-value here is significant or not. And the lower the p-value, more significant our difference is. Okay, so basically p-value indicates the probability of observing the difference between these two groups just by pure chance. Okay, so now that we have this t-value here calculated, we move on to the next one, which is this one here. Right, the two t-tasks are done, basically. Checking again the number of individuals for Semoda, it's right. Number of individuals for Gariana, it's right. Now let's move on to the regression analysis, the linear regression. To do this, what we're going to need is not individual values for each plant. What we need here is the average value for each provenance. So in order to do that, what I'm going to do is I'm going to create in here table, and I'm going to basically copy this table from here, right here, and now I'm not going to use the paste special because I want the same formatting from that table. That looks great. What I can also do here to improve our view here, I'm going to remove grid lines, so now I have it cleaner. So coming back here, we need average values for 2007 height, average values for 2017 height, and average values for 2019 circumference. Okay, so 2007 height, 2017 height, 2019 circumference. It's great. And I want the same formatting from here, right here. So I can just click on this right here, and great, now I have the same formatting. There are many ways to calculate the average. So one way to do that is to take one provenance at a time, let's say provenance 1. So here I have values just for provenance 1. I don't want to do this 13 times because I have 13 provenances right here. So what I'm going to do is write a formula to pick only values coming from provenance 1. I'm going to deselect everything here. Now I have all my values. I'm going to go back to my table, and I'm going to write down first equals average if. So this is the function I'm going to use to calculate the average value for all individuals in provenance 1. So average if. I open the parentheses here, And the first argument that the formula is asking is the range. I'm going to select this range right here, provenance. So I'm going to select everything in this column here. And then you will see right here that we have this range in our formula. And now it's going to ask for the second argument. If I put a comma here, it's asking for the criteria. Okay, so I'm going to go back to my table. Basically, the criteria is provenance 1 right here. Then the third argument is to calculate my average. So I go back here. Right now I'm calculating height in 2007. So I select the values from this column. So I have my average value right here for provenance 1. Now, what I want to do is I want to repeat the same thing for the other provenances. And there is a way to do this without having to write down the formula over and over again. What we can do is I come right here in my formula, I click between column B, row 2, and just click F4 in your keyboard. And then it will basically put this $sign here. And I also want to put another $sign here. I can also just click F4 right here. Okay. So basically what this is going to do is to keep this range the same every time. Okay. And I also need to keep the same range for this range of values right here. So I do the same F4, F4. Now what I can do is just, you will see that my cursor is going to change, right? Right now it's white, and then when I come close to this little green box here, it's going to turn black. Once it's black, I can just click and drag down to all my cells. And here it is, right? So it changed the formatting, so I can just do the same thing I did before to reformat my table. So we can just round this right here. Now I want the same thing for heights in 2017. So let's do it. Great. Now we have all the 3 variables that we need in our calculator right here. Remember always to indicate here the unit of your variables. So let's put the unit for all the variables here. Right. So now we have it, right? Great. So here we have a big table with lots of information, climatic variables, and the 3 variables that we need in our calculator. So I'm going to just take 2007 height and transfer to here. Again, paste special values, good. We now have the values here. We can go back to our table, copy 2017 height. Paste values, good. Remove some decimals. And let's add the third one, which is this one here. Paste values, good. Good. Now, based on your hypothesis, you were going to add the provenance climate right here, which is going to be our independent variable, to test against the dependent variable. We're going to first test for this relationship between provenance climate and 2007 height, and then we're going to test for the same climatic variable against the 2017 height. Based on your hypothesis, my hypothesis here, I'm going to just test mean summer precipitation. For the sake of the exercise, I'm going to select this variable. I'm going to paste the values here, and what we have here is the relationship between mean summer precipitation and 2007 height. It's not significant. So p-value, it's higher than 0.05. It means it's not significant. And because it's not significant, the calculator is not giving us a r-squared, neither a slope. For the second relationship that we are testing here, so the second linear regression, we do have a p-value lower than 0.05. Therefore, it's giving us the r-squared right here and also the slope. And this is going to become clearer once we make the graph, okay? Okay, great. Now that we have all the stats calculated here, I'm going to show you how to produce the graphs requested for your report. So first of all, let's have a look at the bar plots. So I'm going to create a new sheet here called bar plots. And to produce the bar plots, what we're going to need is the average values for Gariana and Semoda. So let's calculate the average. So I'm going to bring the two names here so I can copy and paste, transposing the name. So I have Gariana and Semoda here. Since we are going to produce a bar plot for each t-test, so 2017 height, but we're going to also need, besides average, also standard deviation, because in our graph we're going to also plot error. I'm going to put here the same name. So this is going to be the average, standard deviation. So first of all, let's calculate the average for height in the variety Gariana. Average all the values right here. Great, we have the average, and then we also need the average for Semoda. Select all the values. Good. And then we're gonna need the standard deviation. Which we're gonna use this as the DEV function, open parentheses, and then select the values for Gariana, and then for Semoda. Great, here we have our values, and then, so now that you know how to calculate average and standard deviation, I'm gonna leave the number of stems open for you to do by yourselves, okay? So everything we need is here. I'm going to insert a bar plot graph. We don't need the title. Okay, so here's our graph with the average 2017 height for variety Gariana and also for variety Simoda. So don't forget to add the unit here. I'm not going to add right now just to make it shorter for you, but you know that you have to add mean height of 2017 or something like that. And then another thing that we are requesting you to do is to add the error bar with the standard deviation. So we're going to double click here in one of the bars, and then we click right here in the options, error bars. And instead of selecting standard deviation right here, we are going to click on more error bars options. And Excel is going to give us a random error bar. This is not what we are looking for. So what we are looking for here is right here, custom specify values. Okay. So since we have both varieties here in the same graph, we're going to select for the positive error value the standard deviation, and then for the negative error value the same values, because what we want to plot here is one standard deviation above and one standard deviation below the mean. So this is exactly what we want. Great. So here I have my bar plot with error bars representing the standard deviation. So when you put the graph in your report, don't forget about the caption. Is very important. Talk about the species. Talk what you are plotting here in the graph. What is the error bar representing? What are the units? Don't forget about your captions. So you can go ahead and do the same thing for the 2019 stamps. Okay. Okay, so now that we have our bar plot, we are going to move on and produce our scatter plots to see if we can see any decline, any relationship between one of the climatic variables that we selected and growth, for example. So I'm going to use 2017 height and mean summer precipitation. So I'm going to copy this table here and move to another sheet. I'm going to paste special and values. Then I'm going to paste again because I want that formatting. And so here I have the table that I'm going to use to produce my graph. I'm going to select a scatter plot, and then I'm going to select the data. Create one series here, and the x-axis, what we're going to put is our climatic variable. In my case, mean summer precipitation. In my y-axis, the dependent variable, I'm going to use the height from 2017 for all provenances. And here's our graph. So I'm going to change some little things here because that's going to make graph a little bit nicer. Okay, so I'm going to change the axis options. I'm going to start at 100 centimeters. The maximum is good. Maximum is good. So now it looks better. This, we don't need this. Mean summer precipitation. Now here we can see that decline is quite strong. And this explains why our p-value was significant. So now what we're going to do is we're going to add the trend line. So we know that was significant, so we can add the trend line here. So it's linear, what we want. And then I can also add some other options, which is, for example, the r squared. And then I could also add the equation here. And this is pretty good. So go ahead and produce your other two scatter plots. Make sure you read very carefully the stats primer, because there you're going to get lots of information about the statistics and a good refresher. That's it.